Like, I don't think she just really sounds like it.
I think that she knows some. I don't care. She's down.
How did you guys do on the rest of that?
Everything except for the height, because we didn't learn like
Yeah.
the formula for the height one.
Yeah, that's okay.
So on the back page and like number 6 and then C and like the columns that asked about the height.
Yeah.
What did you do?
I got 2 meters per second. Assumption that there is no air interference.
So, you're okay on the front, right? Yes?
Yeah.
Okay, what about number 5?
I think I got it.
Okay, go ahead and check with each other and then we'll look at those questions that you have.
Then again, I'll say this one, and then you type in this one.
We don't know the distance. Oh, yeah, we did.
Yeah, we
I meant the
but-
height, sorry.
So then it would be 100%. I think.
That's what I got.
I'm thinking that.
I don't know, I'm just.
So what did you guys get on number 1? Wait, we did number 1, didn't we?
Yeah.
What do you guys get 2?
I got at 5
Me too.
Well, I was confused with that because I'm like, they all accelerate at 1 miles per second.
I got the acceleration constant.
Because it's accelerating, but
Isn't that what she
every
said
time-
yesterday in class?
Yeah, every time the interval is at 10 meters per second. So I'm like,
Well, how would you figure out the height if you know how much distance she's fallen? And you know her original height? There's not like a formula for that, it's just that she starts at 19.6 and you know how much she's fallen, then how would you figure out what her height is? Yeah, subtract how the distance that she has fallen from the height that she started at,
Gotcha.
right?
oh, well then what did you guys get for 3? Can we have a negative height? I don't know what I did wrong then.
Probably nothing. It would just mean if there's a negative,
I'm not sure. I was
Well,
like, 5 seconds to choose a market.
19.6 minus 10.6 is 0.
Or 50 meters.
Oh.
Okay.
I think you're supposed to subtract it from each distance followed. Okay. Is that what you're supposed to do?
yes,
Okay.
mhm, right, because after 2 seconds she reaches whatever, the ground.
Well,
What is she doing?
I think she's
reaching
diving.
She's diving into a bucket of
But she's
water.
not even aimed for the bucket, so are they trying to like show that she dies?
I don't know what she's doing.
Yeah, I know. I was like, she's not gonna land in the bucket.
I don't know how her
Oh, here, hang
ending is
on.
gonna work out.
It says the high platform into a shallow bucket of water. So
But
there's
she's
a
not even-
shadow of water
She's,
into
the bucket is very far away from her.
I guess she's diving into the bucket or she's gonna die.
Yeah.
I think she's gonna die because it doesn't even look like she's going to the bucket.
Yeah.
Like,
It's like,
Can you explain how to do number 6 though? It's just talking about height, but it's like, I don't know.
So 3 seconds.
Can you even get an answer for me?
And you need to know the
no, you have to draw
time.
arrows.
Really?
No,
What?
you have the time. You
That's
need
what it's
to
telling you
know
to do.
Really?
Yeah. The height to which you can.
the height, so that's like the distance. So you would use the distance formula and plug in the time and the G and
How
see
far?
what the,
I don't know. I have
yeah, put in like 3 and then 9.8 and see what the distance would be.
What? Oh, the assumption is that there's
Skylar,
no
welcome to
air
your
interference.
table.
I didn't know how to do it.
Well,
I was confused on that
are you
part.
adding in of what this answer that you got?
You gotta use the formulas, just like you did on the front,
Yeah.
except for it's in a table form.
Ah.
Is the answer you the answer? Do we have to subtract that?
It's okay, I'm just gonna keep this picture.
So you just gotta put those times in the two formulas. See what that equals.
Where's your calculator?
Somebody? Oops.
Oh, you broke it.
I know.
Oh wait.
So, for the height, you take 19.6 minus
The
0.5, oh, 1.225. That's what I got for the distance, but I might be wrong. Is this what you got for your distance?
For what?
Your distances? That's a 225.
The 1.5 and, the first one, the first and the third ones are different,
Oh, poop.
the other two is. Oh, wait. Oh, wait,
Yeah, that's what I got.
okay.
Yeah. I'm trying to figure out
It's okay, I'll just go get it.
this knife.
In this file.
Wait, which is my
Cause that's the same thing as divided by.
Oh,
Ooh, that's, oh,
That's
that's
different.
Oops.
That's what you should get. Those tables. Did you get, Lauren, did you figure out number 4?
You
Or,
number
sorry.
6.
6?
I think so. We got 44, I assume that's inches, right, not feet. I guess it's distance.
Well,
Or something.
no, it would be meters. because the acceleration is meters per second.
How does he jump that?
So what did you do? 0.5.
I did, yeah, 0.5 times 9.8 times 3 squared, which is 9.
Yeah. That would be very unrealistic.
It's Michael Jordan in house. He's like
That'd
crazy.
be like way harder than basketball.
Yeah, that's
Be
true.
harder than a building.
No, okay, never mind. That's a little unrealistic.
Yeah, 44.1 meters. So, yeah, I don't
Can't.
really think he has
Unless he has a hard resolve. Would you like us to keep things in decimals or like round up? Cause I just rounded to 44, but does it matter?
Yeah, as long as it doesn't ask you specifically, that's fine. Okay. Better on that? Any questions? No? Okay, we're gonna talk about 4 more,
I just have one question.
yes?
How did you get the height
You
from?
subtract 19.6 from the distances.
Okay, yeah, alright, that makes sense.
Yes. Other questions?
Wait, so for number 6, you would just leave it at 44.1 meters. So- But that's your distance, it's not your height. Aren't they actually the same height?
Yeah, honestly, I think I have to think about that question a little bit more. I've been
Okay.
thinking about it. I don't think it
Okay.
makes sense right
Just wondered.
now. No, very good question. Can you guys see my screen?
No.
I can see.
I don't see it, it's nice and black.
No, still no.
No.
We said earlier that it went black.
Is it not working?
There
There it is. Yay.
Now it's working?
Yep.
Yeah.
Alright, so we're gonna talk about more describing motion with equations. Quantities that are associated with the motion of objects that we have discussed so far. Can you guys tell me what they might be? There's 4 quantities that we have discussed that are related to the motion of objects.
Meters? Or are you
Like-
Like acceleration.
Right, exactly. Right, so displacement, which is distance with direction. Velocity, which is speed with direction. What else did we say?
Acceleration.
Acceleration. And the last quantity is time. If all 4 of those quantities are known, then the motion of the object is fully described. But we're gonna talk about when they are not all known and how we can find the parts that we don't know through the use of kinematic equations. Which are a set of 4 equations that can be utilized to predict unknown information about an object's motion if other information is known. They can be used for any motion that has either a constant velocity or a constant acceleration, but can never be used over any time period when the acceleration is changing.